Hey everybody, Dutch Sense here. 10 a.m. Central Time on Monday, March 23rd, 2015. And I've got you over here on the Wall Street Journal, and we've got more breaking news this month of March. Now, this came out on March 11th, so a week and a half ago. But this is breaking news, nobody talking about it, so I want to bring it to your attention. Japan advances in space-based solar power. Now, what this is having to do with is wireless power transmission using microwaves. Again, we're back to the talk of using microwaves to transmit power. Now, let me just go ahead and read this to you really quick. It is one small 55-meter step for Japan's aerospace industry, but perhaps a giant leap into developing a new energy source for mankind. The Japan Aerospace Exploration Agency, or JAXA, said it succeeded in transmitting electric power wirelessly to a pinpoint target using microwaves, which is an essential technology needed for the realization of space-based solar power. According to a spokesman at the agency, the researchers were able to transform 1.8 kilowatts of electric power into microwaves and transmit it with an accuracy into a receiver located 55 meters or 60 yards away. The microwave was successfully converted into direct electrical current at the receiving end. The experiment was conducted on Sunday in Hyogo Prefecture in western Japan. Now it goes on to talk about space-based solar power, U.S. Department of Energy. I'm going to go ahead and put a video after this. I've had this on my channel now for the last 2 years. Not many people have seen it. You need to see it. Okay? They're using radar to transmit wireless power back in 1975 using the same frequency that our Wi-Fi is on now, 2.45 gigahertz, also Bluetooth. And NextRad radar just a little bit above that, 2.7. So in that 2 gigahertz bandwidth, transmitting wireless power. And all it's about is what's at the receiving end. If you've got an antenna and you hook that up in series with a diode, a low-pass filter, either a bandpass filter or a low-pass filter, and then run that into a DC to DC converter, that's your wireless power setup, guys. Here, I'll put a diagram here on the screen, and I'll put links down below. Now, you're playing with potentially, I suppose, a lot of power. So if you do build this, of course, be careful. But, I might have to look into building a couple of these. I mean, if it's proved that 2.45 gigahertz can be transmitted, then we need to build the receiver antennas now, the Rectenna, RECTENNA, with the receiving diodes. The diodes is going to convert, supposedly, the AC that develops in the antenna to DC. It's a rectifier. So you need a rectifier diode and then a low-pass filter, and then you're going to need to obviously convert that from into some kind of usable DC. But potential out of the air is whatever the transmission source is. So I know around me, for instance, all my neighbors have their own Wi-Fi running at roughly the same gigahertz bandwidth. Several of them most likely the same even routers. So if you got the same kind of antenna to pick up that signal, well, guess what? You're going to be able to convert that into power. Now they're doing this on a massive scale, collecting the solar power and beaming it down to Earth in just massive amounts. But locally, at your house, you could theoretically build your own and convert that into power. And you could talk on your cell phone right next to it. It's not going to mess with your cell phone signal at all because it's only picking up. It's not transmitting anything. It's not sucking in anything like a black hole. It's literally whatever hits that antenna is going to be converted into power. And you could stand right behind it, right next to it, in front of it, and still talk on your phone. And there's no loss of power to the cell phone company. No harm, no foul to anybody except for pulling that out of the air. It's already going to hit your walls. It's already going to go into the ground, whatever. You're just pulling that out of the air and converting that into DC current. And that's what wireless power is. That's how they're able to do it with microwaves. Microwaves travel across the distance, hit the antenna. The antenna, of course, AC current in the antenna, travels down the antenna. Then you need a way to rectify that into DC current that's usable. And, of course, then there's the apparatus for wireless power transmission. I hope that explains it, guys. Big news again. Of course, you need to come over to my channel and check out the other stuff that's going on. I'll put links down below to my blog, to my website, So you can check out what's going on over there. But we've got another breaking news story in regards to directed energy today, and that's that Boeing filed patents for force field technology using microwaves that blocks incoming explosions, the shock waves from explosions. So if an explosion happens, it will block the shock wave and protect whatever the truck, the Humvee. They've got a diagram of a Humvee with two transmitters on it and forming a scalar, pointing in a certain direction, targeting that down to a point, and that's where plasma forms, and it forms a plasma shield that protects the object that's transmitting. It's crazy, but there it is. They filed the patent on it. They just did that. So this is kind of like breaking news today across the board, apparently, on weather modification. I'm surprised nobody else talked about the wireless power transmission. Again, guys, I've had it up on the channel. Let's just go ahead and show it to you here. And, of course, I'm going to play it here at the end. Let's go ahead and scroll down. Here it is, right here. Radar used to transmit power to distant rectenna. And again, the rectenna is the receiver antenna, receiving antenna, that converts the energy into DC. You're taking microwave that's coming down an antenna, you're rectifying that into a DC current, and then using that DC current. And the efficiency is greater than power traveling down a wire, if that gives you any perspective of what we're talking about here. So if you've got a cell phone tower up the street broadcasting out at 35,000 watts, I suppose potential, if you had an antenna up sticking up off the top of your house, the potential for receiving that is up to 35,000 watts, right? I mean, if the law, or a little less than that, 85% of that, whatever 85% of 35,000 watts is, but that's still a huge amount of wattage available. And we're talking about voltage and amperage available out of that wattage. So what kind of volts, what kind of amps, that's going to depend on, I guess, on your antenna and on your rectifying diode. So I guess the better the diode, the better the antenna, the better the wattage you're going to get out of the air. It's just that simple. And if you guys understand electronics, you know exactly what I'm talking about there. So the diagrams are down below for that from the NASA experiment done from the Goldstone radar here in 1975. And the article link is down below, so you guys can go check out the article that was released on this by the Wall Street Journal. It's amazing times, guys. It really is amazing times to be alive. Be safe.